Question 31. The diagram below shows two human systems, namely system Z and the circulatory system. The arrow shows the directional movement of two gases entering and leaving the human system. So let's start highlighting some points. Okay, so when there are two gases, the two gases that we are familiar with would be your oxygen and your carbon dioxide. Okay, so let's take a look at the diagram itself. So we know that something that is actually going into your circulatory system and then coming out of it. Now we know that basically whatever that's supposed to go into your circulatory system will be oxygen, because oxygen is needed to be delivered right to all parts of the body. So therefore what you want to go into the circulatory system is actually your oxygen. Okay, your oxygen would be the one that actually allows your cells to respire, so you will need that. Okay, and then after that you will actually, for gas R, you want to get it out of your system. That is actually carbon dioxide. Okay, so you have this two gases. Now identify gas Q and system Z. So like what we have done earlier, this is actually oxygen. Now system Z is actually your respiratory system. Now how do I know that it's a respiratory system? If you look at it, your carbon dioxide is actually going into it, and then after that it gets removed, right? So that is actually something that your respiratory system would do. Now explain which part of the plant performs similar function as Z. So your answer would be your stomata. Okay, that is the part. So the stomata allows for gaseous exchange to happen. In plants. Okay, why is gas R important to plants? So as identified, gas R is actually carbon dioxide. So if you recall, I always tell you to write down the word equation for photosynthesis at the beginning. So you would know that, okay, for photosynthesis, carbon dioxide is actually important. Okay, so plants take in gas R. You can bracket it and then write down carbon dioxide. Okay, moving on to question 32. Silver connected a syringe to a container with a capacity of 300 as shown. Okay, so the container has a capacity of 300. He then used two identical syringes and pumped in 50 cm³ of air into the container, one at a time. What would be the volume of air in the container? So the volume of air in the container, okay, will still be at 200 cm³. Please be careful of your units. Units are very important. Now the reason why is it 200 cm³ is we know that in totality, the total amount of the capacity of your container is 300 cm cube. Now, water itself has already occupied 100, and we know that water has a definite volume. So as such, if you take 300 subtract away 100, you would know that the remaining 200 cm cube belongs to your gas or your air. Now we know that air does not have a definite volume, it can be compressed. So therefore, even though you've pumped in 50 cm cube of air 2 times, alright, it will still be fixed at 200 cm cube. Now, would the mass of air in the container increase, decrease, or remain the same after 2 pumps of air had entered? Give a reason for your answer. Now, the answer would be, okay, it would increase. Now, why is this so? Now, what happens is that, remember, mass is defined as the amount of matter that makes up a substance, right? The amount of matter. So, just to explain about this, okay, now I'm drawing for you 2 diagrams. In the first diagram, A and B, A has 4 particles of air. Okay, this is the amount of volume that it occupies. Can you see how far they are apart? Now what happens is when you pump in more air, you're putting in more particles, correct? Now when you put in more particles, they fill in the empty spaces here. You see it's filling it in. So there are lots of empty spaces between the particles of air. Okay, so they can be compressed into the same volume. So in this case, the amount of matter that is used to make up the air has increased. Okay, so the mass would have decreased. Alright, so what is the reason for it? Would be she has pushed, oh Siva has pushed in the plunger 2 more times. That's your evidence. So more air added into the container. Right? Next, Siva inflated his boat and went on a full day paddle on a hot day as shown below. He was advised not to pump too much air. Okay, while inflating the boat so it will feel firm and not hard. Okay, it was to prevent the boat from tearing while he was paddling under the sun. Explain why there could be a possible tear in the over-inflated boat while he was paddling under the sun. So in this case, in this question, they are actually testing you on the concept of expansion, right? So what are some of the hints? So hot day, sun, all this would point to a heat source of some sort. And then you would know that basically, if let's just say your air expands, it will need to occupy more space. So when it needs to occupy more space, all right, there may be not enough space, and that's where the expansion would be detrimental, and then your boat may burst. So in this case, you need to say that in the first place, Siva has pumped in too much air. Okay? right? And then the next part, you have to say that then the air would have gained heat from the sun. And expanded. Further causing the tear. Alright, so this is a case whereby it's not that you should not pump air, but you should not pump too much. Okay, so they actually accounted for some allowance, but because Siva didn't listen and pumped too much, that's where he got into trouble. Okay, questions 33. Doctors Peter and John, wearing spectacles of identical materials, had a discussion in an air-conditioned room. It was observed that the inner surface of Dr. Peter's spectacle, okay, fogged up each time he spoke, but Dr. John's remained clear. Okay, explain why Dr. John's spectacles did not fog up. Now, whenever there are two diagrams, I always tell my students to mark out what is the difference. So the difference is that there is the mask is being taped across the nose bridge and cheeks, whereas this side there's no such thing, and this one has the fogged up glasses. So when you think about it, what is this fog that they are talking about? I think it's important, right? So this fog is actually tiny water droplets. So if there are tiny water droplets being formed, then some form of condensation must have happened, correct? And if there's some form of condensation happening, then you would want to look for the source of water vapor. So with that in mind, you would have already understood that the difference between these two is that this Dr. John probably had a source of water vapor being stopped, whereas this one, the source of water vapor is able to reach the lenses. So over here, they told you that the mask was taped up. So when you think about it, when you respire, you're breathing out water vapor. So by taping the mask, you're actually preventing the mask, the water vapor from escaping from the mask and touching your glasses. Whereas in this case for Dr. Peter, the mask wasn't taped, so water vapor that he breathes out could just touch the lenses. Alright, so he's talking about Dr. John, right? So first things first, you have to say that, okay, his mask was taped across his nose bridge and cheeks. This prevented the warmer water vapor from his breath from moving towards or moving upwards, okay? Moving upwards to touch the cooler surface of his lenses. lose heat to the lenses and condense into water droplets, which is essentially your fog. So it's very important to identify where is your source of water vapor. Next thing, identify, okay, where is your cooler surface at which you will lose heat to, and then it condenses into water droplets, which is your fog. Right? Now, then it said when they moved into an outdoor garden to have the discussion, Peter observed there was less fogging on the inner surfaces of his lenses compared to when he was in the air-conditioned room. So the main idea is because there is now a smaller difference in temperature. So remember, I always explain this to you. Heat gain, heat loss. Heat gain is always from a region of higher temperature to a region of lower temperature. So if the two regions' temperature is of greater difference, then your rate of heat loss will be faster. So think of it as like a gradient. Okay, so this is your higher temperature, this is your lower temperature. So the steeper your gradient is, okay, you put a ball here, the faster it will roll. So the ball represents the heat that is being transferred from a region of higher temperature to a region of lower temperature. So the greater the difference, the faster the ball will roll. Similarly, the greater the difference between the two regions of temperature, the faster the heat transfer would be. Okay? So explain his observation. So because when he moved out to the garden, let's just say his breath was about 37 degrees Celsius, give or take. Okay, in the aircon room, it was probably about maybe 17 degrees Celsius. The difference between these two is a good 20 degrees Celsius. But when you move out to the garden, maybe say the garden is about 25 degrees Celsius, the difference is only the 12 degrees Celsius. So can you see that the difference is smaller? So because there's a smaller temperature difference, the rate of heat transfer will also be slower. Therefore, there will be less condensation or slower rate of condensation. All right, resulting in less fogging. Okay, so let me just pen this down for you, the answer. Between the cooler lenses and warmer water vapor from his breath, which reduces rate of condensation. Right?